Hello everyone. In this session, we will going to discuss page replacement policy. Before starting the example of page replacement policy, let me tell you what is page, why we need to replace it. We all are aware that operating system known as a resource management, along with the management of file, device and driver, it will going to manage memory. It works like our brain in terms of memory management. Whatever we can see, we can read or we can listen, that is going to store somewhere in our brain's memory. So next time we will able to identify that things. As per the definition of operating system acts as an interface between the hardware and software. Software processes are executing in CPU needs to store in memory. Memory is fixed or finite in size. Memory is in form of such kind of hardware chip. If we try to store all the processes at the same time in RAM, then RAM size will going to occupy and other processes has to wait until the size will become free. This will reduce the processing speed. User has to wait until the space will become free in that particular memory. So it will take more waiting time. User will going to get frustrated. Solution of this problem provided by the virtual memory. Virtual memory is a software that provides illusion that we can store all the processes in memory and execute it within good speed. In last lecture, we have gone through the types of memory allocation. It was non-continuous and continuous. Continuous memory allocation having problem of internal and external fragmentation. That's why we have moved to the non-continuous memory allocation. In non-continuous memory allocation, the processes are divided into pages and memory is in form of frames. These pages are going to store into frame of RAM, but not all at the same time. If I want to take the viva of whole class, then I cannot call whole class together. I have to call some of the students from that particular class, like roll number 10, 11, 12, and 13 come for the viva. Same way, our pages all together are not going to store into that particular RAM. Operating system is multitasking. We are performing more than one task together. We are using PowerPoint. We are using Photoshop. We can even listen the audio. We can even browse through the internet. So if I'm working with the internet browsing, the other processes are going to get minimized in background. So these minimized processes are going to store somewhere in the memory of hard disk through the virtual memory. And when I'll start execution of any of this process, that will come back to the RAM. And this is done by the virtual memory for the utilization of memory space by replacing this used and unused pages. And for replacement of these pages, we are applying certain replacement policies. The first one is FIFO replacement policy. As per the name such as FIFO, first in, first out. The process which comes first has to leave the first. Its example is queue of ticket booking system. If somebody wants to book a ticket for a movie, that particular person is first in line. He will going to get the ticket and then he will going to leave first that line. Same way, the pages which come first has to leave the frame first. Let's solve an example. Consider the following page reference string and how many page fault occurs. Assume the 3 frames. Find out using FIFO. We have to draw one table. First, we have to copy the reference string in this table and the 3 frames are given. That's why we have to take F1, F2 and F3, 3 frames. We have to find out page hit and page miss. If that page is already available into that frame, then we can say page hit occur. And if the page which come from the reference string is not available into these frames, it means that page miss occur. So whenever page miss will be there, I'm putting the star. Let's see one by one. 7 will come first. It is not available. It is coming first time. That's why I have to put star. Then 0 will come in frame 2. Again, I have to put star because page fault or page miss. Then 1 will come. 1 is not available. That's why I have to put star because page fault, page miss will occur. See here, our size of memory, frame 1, frame 2 and frame 3 is going to get filled by this 3 pages. Now what I have to do, I have to put 2 into this frame. I can put 2 only when I can do replacement of one page, and using FIFO replacement policy, I have to replace the page which came first. Here 7 is going to get replaced because it came first. So I'm going to replace 7 with 2, putting 2 here, remaining as it is. 2 is coming first time into the memory. That's why I have to put star, page fault will occur. 0 is coming, 0 is already there into memory, so I don't have to do anything. I just have to copy and paste. The page hit will occur, page is already there into the memory. Now 3 will come. Now where I have to put 3, as 3 frames are filled, I have to find out the oldest page. And the oldest page, the page came first is 0. So I have to replace 3 with 0. 0 will going to get priority for the replacement. 3 is coming first time into the memory, that's why I have to put star. Again 0 will come. Now where should I put 0? Here. Now the oldest page is 1. That's why I have to replace 1 with 0. I have to put 0 here. It is coming first time into the memory. That's why page miss will occur. I have to put star. Now 4 is coming. Which one is the oldest? From 2, 3 and 0. From 2, 3 and 0. 2 will come first into the memory. That's why 2 will going to replace by 4. 4 is coming first time. That's why I have to put star. 2 is coming. Which one is the oldest? 4 recently. Then 2 is 0 is occurring only 2 times here. If we can count 3, 3 is 3 times here. So 3 is the oldest one. I have to replace 3. Putting 2 here, I'm replacing 3. 2 is coming first time into the memory. That's why I have to put star. Now 3 is coming. Where replacement occurs? 0. At 0 we are going to replace because 0 comes 3 times. Other are coming 2 times and 1 time. So I have to copy 4 here to remain as it is. 3 is going to get replacement and it is coming first time. So page miss will occur. I have to put star. Now 0 is coming. Where should I put 0? I have to replace 4 because 4 is the oldest one. First came. 0 is again coming first time. That's why I have to put star here. Page miss will occur. Now 3 is coming. 3 is already there in memory. So we don't have to do replacement. And page hit will occur. No need to do star also. Now 1 is coming. Where should I put 1? 1 I am putting in place of this 2 because 2 is the oldest one. You can see count 1, 2, 3, 4. 4 times 2 came. 0 is coming 2 times. 3 is coming 3 times. That's why 2 is having highest priority for the replacement. 1 and 3. 1 is coming first time. That's why page fault. Page miss will occur. Now 2 is coming. Where should I put 2? Now 3 is going to get chance for the replacement because 3 is the oldest one. So I'm putting 2 here in place of 3. Then again page miss will occur. Now 0 is coming. 0 is already there. So no need to do any kind of replacement. I just have to put 0 and the page hit will occur. From this star I have to calculate page miss and page hit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. 12 stars are there. It means 12 is a page fault and the remaining 3 which doesn't have star 1, 2 and 3 is a page hit. So in this way we can calculate the page hit and page miss using FIFO. Now the next replacement policy is least recently used. This algorithm is a greedy algorithm where the page to be replaced is least recently used. Let's solve the same example using this least recently used. The methodology is going to change a bit. Here 7 is coming first time. I'm putting 7 and the page miss will occur, so star. Now 7 I have to copy and paste. 0 is coming. Again page miss. So I have to put star here. 1 is coming first time. So again page miss or page fault. So I'm putting 1 here and putting star. Now 2 is coming. Here the replacement will going to occur. Now we have to find out which is the least recently used page. If I can check one by one. If I'm taking, let's take 1. 1 is recently used. We can see here 0. 0 is again most recently used. If I'll take 7, 7 is the least recently used page. So I'm replacing 7. Putting 2 here. remaining as it is. 2 is coming first time, that's why page miss will occur. Now 0 is coming, 0 is already there, page hit. We just have to copy and paste, nothing to do. Now 3 will come. Now where should I put 3? From 2, 0 and 1 I have to check it out the least recently used page. 0 I have used, it means it's most recently used page. If I go for 2, 2 is again most recently used page. If I'll go for 1, 1 is the least recently used page. So I have to put 3 in place of 1. And 3 is coming first time, so page fault. Now 0 is coming, 0 is already there, we don't have to do anything, page hit will occur. 4 is coming, where should I put this 4? 4 is going to replace with the least recently used page. 0 I have recently used, 3 again I have used. If I'll talk about the 2, then 2 is the least recently used page. I have to put 4 in place of 2, remaining as it is. This 4 is coming first time, so star. Now 2 will come, I have to replace the page, which I'll replace. 4 is just coming, it's most recently used. 0 is again most recently used. From this 3 is the least recently used page. So I'm going to replace 3 by putting 2. And 2 is coming first time, so it is page fault. Now 3 is coming, where should I put 3? For 3, which page I have to replace? If I'll talk about 2, 2 I have recently used. 4 again I have recently used. And the 0. 0 is the least recently used, other are most recently used. So I'm replacing this 0 with 3, remaining as it is. 3 is coming first time, so star. Okay, now 0 is coming. Where should I put 0? I have to find out the replacement. 3 is recently used. 2 is again most recently used. 4 is the least recently used page. You can see here, every time we have to check from the left side. This left side we have to check. So 0 will going to get replaced by 4 because 4 is the least recently used page. And the page miss will going to occur. That's why I have to put star. Remaining I have to copy and paste as it is. Page hit because 0, 3 and 2 is there. 3 is already there. Now 1 will come. Again there is replacement. Where should I put this 1? 3 is the most recently used page. 0 is again most recently used page. If I'll discuss about the 2, then 2 is the least recently used page. I have to replace 2 with 1. So 0, then 3, then 1. 1 is coming first time. So I have to put star, page, miss. Now 2 is coming. Okay. I have to check the replacement policy, least recently used. 0 is here, 3 is here, and the 1 is here. So we can say that 0 is the least recently used page. 3 and 1 are the most recently used page. So I'm replacing 2 with 0, putting 2 here, 3 here, and 1. Page fault or page miss will occur. That's why star. Now 0 is coming. Where should I put 0? 2 is the most recently used page. Again 1 is the most recently used page. 3 is the least recently used page. I have to replace 3. 0 and 1. We have to check at left side. We have to check this side, left side. And put star. Now calculate the star and find out the page hit and page miss. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. 12 is the page miss, or we can say page fault here. And remaining are 3, 1, 2 and 3 is the page hit. Now we'll move for the next page replacement policy. Optimal page replacement policy. How this will going to work, how it will going to replace the page. It is going to replace the page will not be used for the longest period of time with the page which is not going to use for the longest period of time in future. How it differs from the LRU. In LRU we are checking left side, but in optimal we are checking right side. We are checking for the future, the page which is not going to use for the longest period of time in future, that we have to replace. Now let's see one by one. 7 will come. There is a space in frame, so no need of replacement. And it is coming first time, so page hit miss will occur. Now 7 is as it is. 0 will come in frame 2. Again page miss will occur. 1 is coming first time. Again page miss will occur. We have to put star. Okay, now 3 frames are going to get filled by 7, 0 and 1. Now 2 is coming, then which page I have to replace? From the reference string, 2 wants to come to the memory frame. We have to check the least recently used page in future. Let's check one by one. If I will start with 1 is going to use here. We have to check right side. If I'll check 0 is going to use here most recently. If I'll check 7 in the string, 7 will not come for the future reference. So 7 is the least recently used page. So 7 will have higher priority for the replacement. I'll replace 7 with 2. And this is called page miss because again 2 is new in our memory. Okay, now 0 is coming. 0 is already there. That's why we can say a page hit will occur. We don't have to put star here. We don't have to do any kind of replacement. Now 3 is coming. Where should I put 3? Again, I have to check. I'm having 2, 0 and 1 in my 3 frames. If I'll check one by one, let me check 2. Okay, 2 is here. Then I'll check 0. 0 is here. 0 is the most recently used. Then again 2 is the most recently used. If I'll check 1 I'm going to use here in future. I have to check right side, right? So 1 is the least recently used page for the future reference. I can replace the 1 with 3. So 2 is as it is. 0 will remain as it is. 3 I'm going to get replaced. Page fault will occur. I have to put star. Now 0 is coming. 0 is already there. So there is no need of replacement. Page hit will occur. Now 4 is coming. Okay, 4 I have to replace. I'm having 3 places 2, 0 and 3. I have to check one by one. If I'll check 2 is going to use here. In near future, most recently used is 2. If I'll talk about 0 is going to use here. And if I'll talk about 3, then 3 is going to use here. So 2 and 3 are the most recently used, then 0. So 0 is having priority of the replacement. So I'll replace 0 by 4. And the page miss will occur. I have to put star. Now 2 is coming. 2 is already there. Page hit. No replacement is required. Type as it is. Okay, now 3 is coming. Again 3 is there in our string. No need of replacement. Keep it as it is. No need to put star as page hit. 0 is coming. I'm having 3 possibilities of replacement in frame 2, 4 and 3. Let me check one by one. 2 is using here. Then 4 I'm not going to use anywhere. And 3 it is used here. So in future 4 is not going to use anywhere. It is least recently used page. I'm replacing 4 with 0, 2, 0 and 3. 0 is coming first time. That's why page miss will occur. Now 3 is coming. 3 is already there. No need of replacement. Keep it as it is. Page hit. 1 is coming. Where should I put 1? If I can check 2 is the most recently used page. Again 0 is going to use most recently. So 3 is the least recent use for the future reference. I'm replacing 3 with 1. And page miss. 2 is coming. That is already there. No need of replacement. Page hit. Because page is available into memory frame. 0 is also available from the reference string. 0 is available into the memory frame. So again page is hit. No need to do any kind of star. And I have to calculate the star. 1, 2, 3, 4, 5, 6, 7 and 8. 8 are the page miss. And the remaining 1, 2, 3, 4, 5, 6 and 7 is the page miss. So these are the ways of page replacement: FIFO, LRU and optimal. Thank you for listening me. Have a nice day.